Hello everyone and welcome to my lesson on momentum. As always, we'll start with a quick quiz, so if you pause the video, you can have a go. Check your answers. If you're right, give it a tick. If you got it wrong, then you can write in the correct answer next to it. Today we're going to be talking about momentum. We're going to start by talking about what it is. We're going to look at the equation and how to calculate it, and then later on we'll be looking at the conservation of momentum. Imagine you're going bowling. You have two options. You can have a light ball, which you can throw really fast, or you have a heavy ball, which you throw much slower. Which would you rather? Now, some people go for the light ball, which they can throw faster, and some go for the heavy ball. They both do the same job. They can both knock down the pins. Now, you might be thinking, oh, it's something to do with kinetic energy because I've got an object moving. And there's another quantity which is very, very similar. Not the same, but similar. And it's called momentum. And momentum measures sort of how much oomph an object has. So how much oomph that ball has and how easy it can knock those pins down. Here's the equation. Don't write it down. Just have a look. Momentum is equal to mass times velocity. So get the mass, times it by velocity, and you get the momentum. On the second line there, we've got the symbol equation. P equals mv. We use P for momentum. M is used for mass, and N is something else, and O looks like it's 0, so P is the next one, I think. P equals mv. The units for momentum is kilogram meters per second. If you have a look at mass, that's kilograms, and velocity is meters per second. So times them together and we get kilogram meters per second. I've covered up the boxes. Pause the video and try and write down what each of those 5 boxes, what's under each of those 5 boxes. If you want to, I'll put the answers up. You can check yourself. And if you get any of them wrong, that's fine. Just cover them up and have another go. It's quite good to wait until you've got all 5 of them in your memory, and then we can move on to the next step. On the board are 2 different objects. We've got a very massive lorry, so a lorry with a lot of mass, and we've got a very small light bullet, but it's going very fast. Now here's 2 different objects that can have a very large momentum. We can have the lorry with a large momentum because it's got a lot of mass, and we've got the bullet with a large momentum because it's got a lot of velocity. In fact, they could have the same velocity. We could have, for a silly example, 100 times 2 is the same as 2 times 100. So as long as one has more mass, the other one has more velocity, they could end up with the same momentum. What's important is that momentum depends on 2 things, mass and velocity. I want to have a look at 2 different equations on the board. One of them is momentum, mass times velocity, and the other one is kinetic energy, which is also to do with moving objects. And the equation is half mv squared. Look how close they are. They're very, very similar things. So if something has more momentum, it will have more kinetic energy. They're very, very similar. However, they're not the same. Energy is measured in joules and momentum is kilograms meters per second. They're different things, just like length and time are different things. So they're different, but they're very, very similar. We're going to use the equation now. I'm going to have a go on the board and show you exactly what it's meant to look like. And then you can have a go on the worksheet, which is in the description, and it's also on Show My Homework. Now there are 2 important parts to this. One is the layout and 2 is the units. So a dog has a mass of 2 kilograms and it runs at 3 meters per second when it chases a cat. What is the momentum of the dog? So I'm going to start off by writing mass is 2 kilograms. That's the right unit. The velocity is 3 meters per second, which is correct. And momentum is question mark, because I don't know the momentum. Draw a line. Write the equation. It's the same every time. P equals mv. Put in the numbers we know. We don't know P, so I'll leave it as P. We do know M, so I'm going to write down M is 2. And we do know V, so I'm going to write down 3. And now we're left with the equation P equals 2 times 3, so therefore P is 6 kilograms meters per second. And that's the answer. Having a go at question 2. Question 2. A ball has a mass of 800 grams. So I'm going to write that down. Mass of 800 grams. Now, alarm bells should be ringing because that is not the correct unit. It is not measured in grams. In physics, we always measure something in kilograms. Now, if I write down that 1,000 at the top, at the very top, I'm writing down 1,000 grams is 1 kilogram. There's 1,000 grams in a kilogram. Therefore, 800 is not quite 1 kilogram. It's a bit less than 1. We can work out that this is 0.8 kilograms. And now it's in the right units. The velocity is 2 meters a second. And what is the momentum of the ball? Draw a line. So far, I've just taken numbers from the question. Write down the equation, P equals mv. We don't know P, so I'll leave that as P. We do know M, it's 0.8. And we do know V, so times 2. And now we're just left with 0.8 times 2, which is 1.6 kilograms meters per second. Question 3. A train has a momentum of 12,000. So I'm going to write over here, momentum is 12,000 kilograms meters per second. It has a velocity of 4. Velocity is 4 meters per second. What is the mass of the train? Mass of the train. Don't know. Draw a line. It's the same every time, and the equation is the same every time. P equals mv. Now we put in the numbers we know. I do know P this time, so directly under P, I'm going to write 12,000 is equal to mass, which I don't know, leave that as m, times the velocity, which is times 4. Now on this side, I've got times 4, so we need to do the opposite. Divide by 4, both sides. So on this side, I'm left with the mass, because it's been times 4 and then divided by 4. And this is 12,000 divided by 4, so the answer is 3,000 kilograms. Perfect. This last one is quite tricky. So if you're not feeling that confident, you might have seen what I've done on the board so far. You can jump straight now and have a go on the worksheet. There are 3 sections at the start, section 1, 2 and 3. The answer at the bottom. You can have a go, let out like mine, and check your answers. If not, you can carry on watching this last one. A particle has a mass of 4 milligrams. 4 milligrams. So I'm going to write down mass is 4 milligrams. Now, 4 milligrams is not the right units. Milli can be written in standard form as 4 times 10 to the minus 3 grams. It's 1,000th of a gram. So you could have done 4 divided by 1,000 to get grams. But that's still not in the right units. We need to divide it by 1,000 again to get into kilograms. So we've now got 4 times 10 to the minus 6 kilograms. Now it's in the right units. It has a momentum of 8. Momentum of 8 kilograms meters per second. How fast is it traveling? Draw a line. Write the equation, P equals mv. The momentum is 8. The mass is 4 times 10 to the minus 6 kilograms. Oh, wasn't meant to do that. Times by the velocity. Now to solve this, that's times 4 times 10 to the minus 6. So I'm going to divide by 4 times 10 to the minus 6 on both sides. Divide that by 4 times 10 to the minus 6. So therefore the velocity is equal to, you could use a calculator, 8 divided by 4 times 10 to the minus 6. Which is 2 times 10 to the 6 meters per second. Very, very fast. So a tiny, tiny, tiny particle, 4 milligrams, 4,000th of a gram, has to travel really, really fast to have a momentum of 8. Okay, once you've watched my workings, you can pause the video, keep them on the screen, and then have a go at the worksheet. Do as many questions as you can. If you're feeling confident, you don't have to do the first few questions. You can jump to section 2 or section 3. Next, we're going to calculate the momentum of a system. A system is something that has more than one component. So you might have 2 objects that hit each other. You might be a car that hits another car, or a bat that hits a ball, or there could be multiple objects. Now, momentum is a vector. A vector is something that has magnitude and direction. Direction matters. So we're going to have a go on the left, these green ones first, and our system is made up of 2 blocks, and it looks like they're going to collide. To work out the momentum of a system, you work out the momentum of one object and add it to the momentum of the other. So I'm going to work out the momentum of this object on the left, and that's going to be, the total momentum is going to be 2 times 5. That's the momentum of that box on the left. 2 times 5. And I'm going to add it to the momentum of this box. 3 times 4. So therefore the total momentum is going to be 2 times 5, which is 10, plus 3 times 4, which is 12. So we can get the total momentum to be 22 kilograms meters per second. And that's how to work out the momentum of more than one object. The total momentum is the momentum of that one plus the momentum of that one. And we can add them together because they're vectors. Let's have a look at the question on the right. Here's another system. I've got 2 objects and they're going to collide. Now to work out the total momentum, I do the same thing. The total momentum is going to be the momentum of the box on the left. So it's going to be mass times velocity, mass times velocity. And I'm going to add it to the momentum of the other box, which is going to be mass times velocity. Now there's a really, really, really important part in that bracket. Because the velocity is traveling in the opposite direction, we must have a velocity of -2. So on this screen, everything going to the right is going to be positive. So I've got +3, +4 and 5 and +5. But anything going to the left must have a negative velocity because velocity is a vector and direction matters. So the total momentum is going to be 40 times 5, which is 200, plus 20 times minus 2 is minus 60. So the total momentum is going to be 200 minus 60, 140 kilogram meters per second. And that's the total momentum of that system on the right. What I want you to do now is pause the video and have a go at calculating the momentum of these 4 different systems. I'll put the answers up in a minute. Okay, I'm going to talk my way through this. The total momentum of this system is going to be mass times velocity plus mass times velocity. So therefore the total momentum is going to be 2 times 4, which is 8, plus 3 times 5, which is 15. So the total momentum is going to be 23 kilograms meters per second. Next, we're going to do the red one. The total momentum is going to be mass times velocity plus mass times velocity. Remember, the object is going the opposite direction, so the velocity would be minus 1. Total momentum is going to be 20 plus minus 6. So the total momentum is going to be 14 kilograms meters per second. Perfect. Next, we're going to work out the green one. The total momentum is going to be mass, 100, times velocity, minus 5, plus the mass times the velocity. Now here I've considered anything to be left to have a negative velocity. I've always done that. I do that with all my questions. Now it doesn't actually matter as long as you're consistent. So if you want your left to be positive, that's okay. So we could use positive and positive. It just means the direction is you've considered left to be positive. So you can do it that way as long as you're consistent. Anything to the left is positive, then anything to the right would be negative. Or you can do it my way, where everything to the right is always positive and anything to the left is going to be negative. The total momentum is going to be 100 times minus 5 is minus 500. And 400 times minus 2 is minus 800. So the total momentum is going to be minus 1300 kilograms meters per second. Last one. Total momentum is going to be mass times velocity plus mass times velocity. Total momentum is going to be 8 times 10 is 80. And 12 times minus 2 is minus 24. If you want to use a calculator for that, but the total momentum is going to be 56 kilograms meters per second. So that is working out the momentum of a system. If you're not happy with that, you can rewind the video, have another go after you've looked at my answers before we move on to the next step. What does the word conservation mean? Have a look at some of the words on the board and see if you can work out from these words what the word conservation means. Conservation means to keep the same. So we've talked about in physics the conservation of energy. That means energy is not created or destroyed. Whatever energy you start with, you must end with. In chemistry, you might talk about the conservation of mass. So when you're doing a reaction, whatever mass you start with, you must end with. It's not lost. The same with, you might have heard of forest conservation. You keep the trees the same, you don't cut them down. Or if you cut them down, you'll plant them again so you get the same number of trees. Or maybe elephants. If you want to keep elephants conserved, you want to make sure that you don't kill the elephants, because then the numbers will start to decrease. So conservation means to keep the same. This is one of the most important laws in physics. It's called the law of conservation of momentum. And it says, for a closed system, so a system that we looked at earlier, each one, the total momentum before is equal to the total momentum after. So if you work out your system and work out whatever objects are in that system, you add all their momentums together. After they collide, they're going to have the same total momentum. Nothing's ever lost and nothing's ever gained. Whatever momentum you had before, you must have the same total momentum. So each object might change, an object might gain or lose, but in total, the total momentum will stay the same. We'll have a look at a couple of examples in the next slide. Here's an example you might get on the conservation of momentum. A train is moving with a velocity of 10. It collides with another train with a velocity of 4 in the same direction. After they collide, the trains stick together and move off at the same speed. Calculated at this speed. The first thing you need to do, always, is draw a nice clear diagram. I've drawn this diagram on the board. You should draw it looking exactly the same. I've made before on the left and after on the right. I drew that double line in the middle to make sure there's a difference between before and after. Now we can work out the total momentum of the left-hand side. That's the total momentum before. And then we can work out the total momentum after. And we know they're going to be the same. So the first thing you should do, draw a nice clear diagram. Don't forget your arrows because direction matters. Then we need to work out the total momentum before. So the total momentum before is equal to mass times velocity plus mass times velocity. And we can work out each one of those. So we've got 10 times 1,000 is 10,000. And 4 times 1,000 is 4,000. So therefore the total momentum before the collision of both of them added together is 14,000 kilogram meters per second. That's the total momentum before the collision. Now we know afterwards they've hit together and they're moving off together. Their total momentum added together is going to be 14,000. That's what the law says. The total momentum before must be equal to the total momentum after. So I'm going to use the same equation, P equals mv. Now I know what P is this time. I know the total momentum of this whole train that's stuck together now is going to be 14,000. And that's equal to the total mass. And because they've stuck together, the total mass of them now is 2,000 times by velocity. Now you could look at this as 2,000 times something is 14,000. So we know that V is 7. Or you can use the same way we've always used. Divide this side by 2,000 to get rid of that. And divide this by 2,000. Therefore, the velocity of those trains is going to be 7 meters per second. You could use a calculator for that if you want. Now that number 7 makes so much sense. Have a look at the numbers again. Go look before. We can see that the train was 10 and it's now going at 7. It's slowed down. Of course it's going to slow down. It's just hit another train. And the other one was going at 4 and that's now going at 7. And that's obvious too. If you hit it with another train going faster, it's going to speed up a bit. So 7 makes a lot of sense. And because the total before was 14,000 and the total after was 14,000, we know that this obeys the law of the conservation of momentum. If you want to follow that again, you can rewind the video and have another look. I'm going to do another example on the next slide. Here's the second example I'm going to do. Ball is moving with a velocity of 12 meters per second and collides with another ball which is stationary. Stationary means stopped. What is the velocity of the ball after the collision? So let's have a look. We've got the total momentum before is going to be 2 times 12 plus 6 times 0. So the total momentum is 2 times 12, which is 24, plus 6 times 0 is 0. So both of them added together is 24 kilogram meters per second. The total momentum of this whole system before the collision is 24. So we know the total momentum after is also going to be 24. So P is equal to mv. The total momentum of this system on the right is going to be 2 times v plus mass times velocity. So therefore the total momentum is going to be 2v plus 18. In fact, we know what P is, don't we? We know that this is 24 because the total momentum before was 24, so the total momentum after is 24. So the total momentum 24 is 2v plus 18. If you were to look at that equation in maths, you could solve it. So we're going to just solve this equation now, and I'm going to solve it by minus 18, minus 18. So therefore 2 times v is equal to 6. Therefore the velocity is equal to 3 meters per second. So the velocity of that blue ball at the top, you can see, is going to be 3. And this is another example of the conservation of momentum, because the total momentum of both balls was 24 before, and after it was 24. Now you've seen me have a go at 2 examples. I'd like you to go back to the worksheet and have a go at sections 4 and 5, which are both on conservation of momentum. The answers are at the bottom. You can check your answers. I'd recommend you draw the diagram first, then do the momentum before, and then do the momentum after. Check your answers. If you're still stuck, you can send me an email. There's one last example I want to go through, and that's slightly harder because if you have a look afterwards, these 2 objects go in the other direction. A particle is moving with a velocity of 5 and collides with a particle moving in the opposite direction with a velocity of 3. If both particles change direction after the collision, calculate the velocity below. So I'm going to work out the total momentum just like normal. Mass times velocity plus mass times velocity. Remember, opposite direction, so this should be minus 20. The speed can be 20. Direction doesn't matter with speed, but the velocity is minus 20. Total momentum is then for 150 plus minus 100. So the total momentum is going to be 50 kilograms meters per second. Total momentum is 50. Now afterwards, we know P is equal to mv. We know that the total momentum is going to be 50. It has to be. So let's do the momentum of the blue box first. This is going to be mass 5 times velocity v, mass times velocity, plus mass 5 times velocity 50. And you can work these out. So 50 is 5 times v is 5v plus 250. Now to solve that, you can just solve this equation now. I'm going to minus 250 from this side and minus 250 from this side. So the left hand side becomes minus 200, because 50 minus 250 is minus 200, is equal to 5v. And that is plus 250 minus 250, so that side goes. Next, I'm going to divide that side by 5 and divide that side by 5. So therefore, the final velocity is going to be minus 200 divided by 5, which is minus 40. Now it's minus 40, and that makes so much sense. If you have a look at the box up there, it's negative because it's going off to the left. So yes, getting a negative number is good. Now this is a really tricky example. If you've managed to follow that, good. If not, just go back and have another look. You can pause the video, have a go, and then look at my answers. That's the last of my workings. If you want to have another go, you can have a go at section 5. There are some tricky ones in there. Send me an email if you get stuck. Don't forget, layout is really important. Always draw a diagram. I recommend it looks like mine with a before and after. And then lay it out just like I've laid it out, and you should get the right answer. If you want to do a final check, be careful of your sign and double check that all of your negatives and positives are in the right place. And if you still get stuck, you can send me an email.